Good morning, students. In the previous video, we discussed about the mathematical derivation of equations of motion. Now, now we have the possibly second last topic to be discussed from this chapter. So, today we are discussing the graphical derivation of equations of motion. All right. So, graphical derivation, that means we need to plot the graph. Okay. So, what sort of graph we need? We need here VT graph. VT graph. VT graph means velocity time graph. So, along the y axis there will be velocity, and along the x axis there will be scale of time. Okay. Now, here let an object is moving with uniform acceleration. Okay. How? Let us see. Here, this is origin point. This is origin point. This point I have taken as D, from where the object will start moving. Okay. From D, the object will start moving. So, this OD will be, okay, U, that means initial velocity of a body. So, OD is U, and from this point D, all right, from this point D, now this will start changing its velocity, and after time t reaching to the point B, like this, here to here, from D to B. This is up to this level we had initial velocity on a body which is u meter per second. Now after time t reaching to the destination of a point B, this velocity is converting into final velocity. And what is the final velocity? Final velocity is v meter per second. All right. Now students, let's complete this graph. How? Draw a line parallel to x axis. Okay. Draw a line parallel to x axis. That means from point D, draw the dotted line from the point D. Draw the dotted line along the x axis. This is x axis, where we have plotted the time, and this is y axis, where we have plotted velocity. Now students, here we have drawn from point D, and now again we will complete this one as well. From point B we are going to draw a parallel line along with the y axis, like this. So let's name it. This is point A, this is point E, and this is point C. So let's complete this dotted plotting in a graph. So here, what is the velocity? V. Final velocity is V. So V meter per second is final velocity. Let's write all these things which are essential in putting up all together the graphical derivation. What we will write? Let an object is moving with uniform acceleration a, let initial velocity of object, which is u meter per second, all right, on a scale of OD. Now let object reaches at point B after some time t, after time t, its final velocity, okay, its final velocity becomes v. All right. So now from the graph, what we can conclude here? From the graph, we can write let OE equal to time, which is t. Again, we can write here from the graph BE. Can you see this? BE. BE equal to AB plus AE, right? AB plus AE. In place of AB, cannot we write this CD? Okay. And in place of AE, cannot we write OD? Yes, we can. Let's write it then. So in that implies BE equal to, in place of AB, what we can write? CD. So I am writing CD plus. In place of AE, what we can write? OD. Okay. Now tell me what is BE. BE is a final velocity. So final velocity, that means V equals to CD. And what is OD? OD is U. OD is U. That implies CD equal to V minus U. Equation number 1. Okay. Now, students, in the previous class, we have discussed about the mathematical formulation of acceleration. So, since we know that A equals to B minus U by T, right? A equal to B minus U by T. So, in place of B, what we can write? In place of B, we cannot write OC. Yes. In place of U, we can write OD by time. Now, OC minus OD gives you what? CD. See here. OC, this full escape is OC minus OD. What is the leftover? CD. So we can write CD by T. So students, which implies DC equals to AT. Consider it as equation number 2. Alright. So from equation 1, what is equation 1? CD equal to B minus U. Okay. Equation 2, CD equal to AT. Both these equations are same? Yes. So from equation 1 and equation 2, we can write B minus U equals to AT. So we will write here from equation 1 and 2 we have what we have b minus u equals to 80. So b equal to minus u will be transposed to the right hand side. So minus u will be turning into positive u. So u plus 80. So this is the first equation of motion which is graphically now derived. Okay. First equation of motion. Now let us discuss about the second equation of motion. Okay. What is the second equation of motion? We have discussed in the previous video, s equal to ut plus half 80 square. Alright. Now same graph that just now we have discussed will be applicable in second equation of motion as well as in third equation of motion. Okay. So we need not to draw the another plotting velocity time graph. So by the same graph, okay, we can have some observation. And what are those observation? Let's see. So this is second equation of motion. We are on the line to prove graphically this one. So students, we write that distance traveled by the object in given time t is given by the area of trapezium A B D O E. Okay. Now let's see that graph so that we could understand that what are we talking about the trapezium ABDOE. Here again we are here with the graph. Okay, look at the trapezium ABDOE. This is the trapezium, students. Okay, ABDOE, or in a better way we can say that what BDOE. BDOE is a trapezium. Okay, so this trapezium contains two geometrical figures. Okay, BDOE contains two geometrical figure. First is this triangle ABD, ABD, and the another one is rectangle ADOE. Okay, ADOE. So students, I hope you have understood this much. Let's come for the graphical derivation. So we write area of trapezium ABDOE equal to area of triangle ABD plus area of rectangle. What is that? AD, right? OE. Now area of trapezium is what? Distance traveled. So we will write S. Okay. Area of triangle ABD, that means half into base into height. Half into base into height plus area of rectangle, that means base into height in that rectangle. So let's see from the graph, half into base into height. Okay, half into base into height in triangle. What is base? Base is AD. And what is height? AB. AD is your base, AB is your height. Okay. In rectangle, OE is your length and AE is your breadth. Okay. So rectangle has two dimensions, L into B. Alright. So we will write, sorry, L into B. Half into B. So what was the B? We will say AD. What was the height? We will say AB. Plus L into B. What is L? L we can write, students, here OE. And what is breadth? Breadth is AE. Okay. Now half into AD. So what is AD there? AD from the graph we can see is time. So I am writing T. What is AB? AB. So AB is what? AB is B minus U, right? AB is B minus U. Now plus, what is OE? O is time. And what is AE? A is U. Okay. All these are equal to distance. S equal to half into T. Now T into B minus U plus UT. So in place of, we know that, since we know that A equal to B minus U by T, so T equal to B minus U by A. Okay. So in place of T we can write B minus, or we need not to write this one, let it be. In place of T, let it remain T. In place of B minus U, in place of B minus U, you can see B minus U equal to AT. So we can substitute here AT plus UT. So B minus U equal to AT, since we are having this relation. So S equal to half into AT square plus UT. So S equal to UT plus half AT square. So this is the second derivation of equation of motion. Okay, students. Now, third equations of motion. What was the third equations of motion? Third equation of motion is V square equal to U square plus 2AS. We will prove this one. Now, again I am going to write, since the distance traveled by an object is given by the area of trapezium. Okay, what was the trapezium? Let's see that same trapezium, ODBE. ODBE. So students, again the trapezium name is ODBE. So we will write area of trapezium ODBE. Now, what is the area of trapezium formula? From the formula of area of trapezium, we know that half into sum of parallel sides into altitude. Altitude means height. So area of trapezium is what? Distance. So I am going to write S equal to half into sum of parallel sides. In trapezium, parallel sides. Let's see what parallel sides we are having in the graph. This one is parallel, OD and BE. OD and BE is a parallel side. So we will write OD plus BE. Okay. OD plus BE. Right? So here sum of parallel sides means OD plus BE into altitude. What is altitude? Altitude means in trapezium distance between parallel sides. So what is the distance between parallel side? From here, this is the parallel side, this is the another parallel side. So this distance is altitude in trapezium. So what is the altitude? What is height? We will say OE. So I am writing here OE. So S equal to half into OD. What is OD, students? We will say U. Okay. What is BE, students? BE is B minus U. BE is equal to B minus U. So I am writing in place of OD U. Okay. Plus BE. Sorry. BE. BE is the complete. Sorry. BE is velocity B. Sorry. Not it is B minus U. BE is B. Now what is OE? OE will be time. So S equal to half into U plus B into time. Now we know that A equal to B minus U by T, since so we can write T equal to B minus U by A. We can put here B minus U by A. So S equal to, this is, now we can write B plus U. So A plus B, A minus B, that means A square minus B square. So B square minus U square by 2 into A, 2A. By cross multiplication, we can write that implies B square minus U square equal to 2AS. So B square equal to U square plus 2AS. So this is the third equation of motion derivation. I hope you have understood this one. Now, the last topic that we do have from this chapter, student, is circular motion. Okay, circular motion. What is circular motion? We say that motion of an object along a circular path. Okay, motion of an object along its circular path is called circular motion. Okay. Now see, try to understand. This circular motion in a body, whatever body is moving in this circular path, the body keeps getting accelerated. It's accelerated motion in a body. Why? Suppose this is a circular path of radius r. Okay. Now the body is here. Suppose the body is here at point A. Okay. So the direction of a body will be tend to or will be tangent to its circular path. Okay. Now here at this point, now reaching to the point B, again the direction of a body will be changed. Suppose the body is reaching to the point C. Now the again direction is getting changed. Now reaching to the point D, again the direction of a body is changed. So students, we conclude that since on a circular path the direction of the object is changing continuously to keep it in the path the motion of an object is called accelerated motion. Accelerated motion. Okay. Now let's find out the velocity. Velocity of a body in circular motion. Okay. What is the formula that we know? Let's see. Velocity equal to distance by time or displacement by time. So what is the distance? Suppose this is a circular path. This is radius r. So suppose a body starts moving from point A and keep going in this circular path, finishing its journey, again coming back to the A point. It means completing one rotation. Yes. So completing one rotation means what? Covering the circumference of the circle. So that's the distance. So we write, in place of distance, we write circumference by time. So V equal to, what is circumference of circle? What is the formula? We write 2 pi r by time. Time is t. So this is the velocity of a body in a circular path. I hope you all have understood this one. Thank you. Have a nice day.